My name is Maedeh Nasri. I'm PhD candidate at Leiden University in the Netherlands. Today, I'm going to present to you our extended abstract titled Role of Movement Data in Creating Inclusive School Settings for Students, which is submission number 2292. First, I would like to talk about the overarching project called the Schoolyard Project. The central aim here is to create an inclusive school environment so that all children, especially those with the special needs, feel welcome and included during the break in the schoolyard. It obviously involves experts from different disciplines, including psychology, data science, school design, and policy making. And we integrate information from different sources, like traditional methods such as self-reports, field observation, video observation, but also modern sensing technologies such as sensor data. And in this way, we can kind of combine all this information to make a clearer picture of what is happening in the schoolyard. And in this way, we can identify the existing limitations and obstacles in the school environment. In today's talk and in this specific research, we want to analyze the role of sensor data in creating an inclusive school policy. We therefore ask, how can analysis of a student's movement data during breaks inform policy decisions concerning inclusiveness at the schools? So obviously, inclusion is not only about the children with the special needs, but it's about creating an environment that enables all children to feel included and welcome. Traditionally, an inclusive school setting could be conceptualized in academic performance of the students, for example. If the performance in education is good, then it means that the school provided a safe, welcoming environment. The same goes for the school attendance. If the school attendance is high, then it means that the school provided a safe environment for students. However, we argue that an individual student may be actively included in the teaching activity under supervision with a structured situation, while being simultaneously excluded from the informal communities such as, let's say, hallways, cafeterias, schoolyards during the break. And that's actually one of the reasons why we focused on the schoolyard and during the recess time. Another point is that in this research, instead of focusing only on individuals and understanding difficulties and limitations as an individual obstacle, we want to put focus on person-environment relationship and define the limitations and obstacles at the school level. And in order to do that, we focus on HEY model, human environment interaction, which was proposed by Kuller in 1991. In this model, there are three aspects identified around the child, where the child is in interaction with these models, but with these aspects, but also these aspects are in continuous interaction with each other and influence each other's performance. Through the next slides, I'm gonna explain each of these aspects, how we could measure them, and share with you the preliminary results that we obtained from the sensor data. So the participants are 76 children aged between 5 till 13 years old from 12 different classes of a primary special educational school. 76% of these students or children are autistic, and 34% are with ADHD as their primary or secondary diagnosis. Children were asked to wear a belt, as you see in this figure, if they are willing to participate in this research, but of course the consent from their parents were received before starting the entire experiment. So in this sensor belt, there are three sensors mounted, starting from left. the GPS logger to measure the location of the individuals, as we all have it in our navigation system. The middle one, the second one, is the proximity tag, which detects the face-to-face interactions. And the last one, the multi-motion receiver, which actually is the accelerometer, gyroscope, and magnetometer together. We again have it all in our smartphones to know how much active we have been in a day or in a week or in a month. It also gives us information that how long we've been cycling or running. So it actually measures the physical activity level and physical activity type. In addition to the unique information that each of these sensors can provide, we can also combine the information with each other and kind of completes the information that we get from each of these sensors. For example, as I said, the proximity tag detects face-to-face interactions, but we also have different types of interactions. Let's say if two people are like running together side by side or walking together, then they wouldn't have face-to-face interactions. So our proximity tag is not able to detect these kind of social contacts, while it's strong and we want to make the picture clear, as I said. So then in these cases, we can look at the GPS data and see how similar their movements are. So we expect that if two child are like running together, then they would have similar patterns of movement, and that could be identified from the GPS data. The other point is that GPS data normally is super noisy. It has some latency because of its connection with the satellites, but also it might have non-uniform sampling rate. We could refine this positioning data using the MMR data. So this is also another added value in having all these sensors together. Another point is that by kind of combining or integrating this information together, we can add the location dimension to the face-to-face interactions, as well as the physical activity levels that we obtain from the MMR sensor. So, for example, from the proximity tag, we could say we could talk about the face-to-face interactions of children, but combining it with the GPS locations, we could say where interactions took place in the schoolyards, which is crucial information for us. And the same goes for the MMR sensor to see how different activity levels are mapped into the floor plan of the schoolyard, for example. And mapping these three sensors to the model that we want to focus in this research, we can actually say that the physical environment or the schoolyard is somehow measured via the GPS loggers, and the social environment is evaluated or shaped by the proximity tag, and the activity is kind of measured with the MMR sensor. And through the next slides, I'm gonna go into the details of each of these like aspects around the child. But first, I would like to emphasize that when we want to look at all these results and visualizations, we want to take into account individual differences. Children are in different age with different social and physical development, different gender, different diagnosis, which means that they have different capacities in interacting with the environment. And this is an important point to take into account when analyzing and interpreting the data. Starting from the first aspect, it's the physical environment, and it's actually directly measured via the GPS data. Using the GPS data, we could create the heat map of the schoolyard, as you see in this figure. So this is like the school building, and around the school building, there is this schoolyard, and you see the warmer colors means it has been more frequently by children, and also the larger dots on the middle of these spatial beams means that the number of students who used it is higher. There are 2 points in this heat map. The first is that the availability of play structures and the proximity to each other could highly affect the way children would use the space. For example, here you see that the crowded areas are around the sand pits, the swings. Also, they are in a close proximity to each other. But the other point is that the motor skills is really important in this analysis. So if you put the heat map of a specific play group compared with the other play group with different age, you would see that children in different ages, depending on their own physical development or skills, they would use the space very differently. For example, we observed that children in younger age would use the sand pits, the swings, and the bikes quite often during the break, while for the older children, they directly would go to the soccer field and start playing with the ball. So in this way, if we want to think about an inclusive physical environment, we should, of course, take into account these individual differences as well as the effect of play structures, its availability and its proximity into account. Another aspect around the child is the social environment, and it's measured by the proximity sensors. Using this proximity information, we could kind of create the social network, and creating the social network by applying social network analysis, we could position each of these children in this network and see where they position and how they interact with other peers within the network. There are a lot of information actually embedded in this graph. For example, all the nodes or children are colored based on their closeness level, which is actually the closeness centrality, one of the most famous centrality measures in social network analysis. The more green actually shows the higher social, the higher connectedness to the network, and the more yellow means the less connectedness to the network. Also, you could see that the links or edges between different nodes and different children are in different thickness. The higher interaction time is indicated via a thicker edge between the pair of nodes or pair of children, and those nodes that are in those children that are in a higher interaction line, they are also located in a closer distance related to each other. So in this way, we can actually, in the next level, we can analyze the group formations and group behavior within this social network and see how different social environment would look like in terms of their social network. And the last aspect in this HEY model is the activity aspect, which we measured it via the MMR sensors. We could calculate the physical activity level from the MMR data, and we could categorize it into vigorous, moderate, light, and sedentary activity. Here in this figure, we have this the proportion of these 4 different categories for 3 different playgroups, starting A from the oldest to the C to the youngest children. And again, here we also observed this fact that children in different ages have different physical skills, and that's why the proportion of sedentary activity is higher in youngest children compared with oldest children who have the highest proportion in their moderate physical activity. So this also emphasized again that children could really be different and use the environment in a different way in terms of their individual differences and capacities. So as to the conclusion, we wanted to answer this question: how can analysis of a student's movement data during breaks inform policy makers concerning inclusiveness at the school? And we focused on HEY model, which categorized, which could identify 3 different aspects around the child, that the child is in continuous interaction with them: the physical environment, the social environment, and the activities. By looking at the sensor data in each of these three aspects, we could identify some elements that could contribute to creating an inclusive school policy. For example, the availability of play structures, their proximity, the schoolyard shape and design. These are all elements that should be taken into account when thinking about an inclusive physical environment. Also, opportunities for interaction, socialization, supervision roles in social environments could be contributing elements. And for the activities, of course, opportunities to play and physical skills. Here, I would like to emphasize again that these three environments or these three aspects could highly influence each other's behavior. And for example, when thinking about opportunities for interaction in social environment, maybe we could first think about a safe, inclusive physical environment that creates this opportunity for a social environment to socialize and to interact with other peers. But also, in terms of activity, the physical environment could really be effective in creating opportunities to play and developing the physical skills, or even thinking about like some activities such as playing with seesaw. When a child wants to play with seesaw, first of all, the physical environment, like the seesaw itself, should be in a schoolyard or in a playground so that the child could use it. But also, if you want to really like enjoy playing with seesaw, you need another person in a social environment to join you to attend this activity. But also in terms of activity, you need to be physically able, like you need to have these physical skills to attend and playing with seesaw. So this is really important to take into account all these internal connection between these aspects when thinking about contributing elements in creating an inclusive school policy. So thank you very much for listening. If you want to know more about our project and also all the sub-projects that are defined within this overarching project, you could go to this website, and if it is more convenient to scan this QR code. If you want to share any experiences, any comments, any questions, feel free to write me an email. I put my email address here. Thanks again and have a nice day.